All right, with that prerequisite vocab out of the way, let's get to object-oriented programming. Time for some new vocabulary. Ready? We're going to learn about classes and objects. Okay, so not necessarily new vocabulary, but we're going to disambiguate and clarify how we've been using these terms. I love disambiguation. I mean, I love the word disambiguation, but I also love disambiguation. Oh, my favorite Wikipedia pages are the disambiguation pages. Okay. A class and an object are different things. They are different things. We use these terms so often interchangeably, which is going to feel frustrating, but don't worry. In just a moment, you will all start using these terms interchangeably too. Sorry. A class defines a type of object. But a class is not an object. A class is a definition of an object. An object is an instance of a class. Objects are concrete entities that are based on a class. And we use the word instance to say that. So objects are not classes, but instances of classes. The class is the definition or the recipe, and the object is the realization, the actualization of the class. Class is like the blueprint, object is the building. Class here is like my grandmother's delicious donut recipe, and the object is a delicious donut. If I eat all my donuts and I don't have any objects left, you still have the class, you still have the recipe. Before we get into inheritance, let's clarify the objects and classes with an example. Let's take a look at our very first C# script, the Rollerball script. This script here is a class. See, it says so right there, class. It's public, that's the class's scope. And then we have this weird mono behavior thing that we've been ignoring so far. And we're going to continue to ignore it for just like another minute or two. Back in Unity, we create instances of these classes by adding them as components to game objects. Each game object is an instance of the game object class, although we didn't write that code, that's codes in the Unity engine. Our player movement components are all instances of the player movement class. This is code we did write. We can have one of these objects in the scene or many of them. Now, you can probably see why we use these words interchangeably. When I'm talking about adding or removing an object's behavior, I really mean adding or removing or editing some member of that object's class. The context of instances doesn't really matter when I talk about making these changes. If I wanted to say I want to add a jump behavior to the object, I would need to go add a jump behavior and write that code and add that to the class that defines how that object behaves. And you can already see the language is kind of tripping over itself, but it's not that bad. So we write our classes and the game creates and uses objects from these classes. Our classes can reference other objects too, like how the Rollerball references the rigid body class, and our specific Rollerball instance here on the player object references this specific rigid body instance here, also on the player object. It uses public members of the rigid body class, in this case the add force function, to roll the ball. So that was a little bit about the classes and objects and the differences between them in Unity. Now it's time to actually get into, the object-oriented stuff, like the entire whole point of this lecture. Inheritance. It's time for the actual lesson. A class can be defined as a child of another class. When we do that, the child class inherits all of the members from the parent class. That parent class, too, could have inherited members from its parent class, and then our child class will inherit all of the members from its parent class and its grandparent class, and so on and so on. In this way, we can model or understand our programming project as a hierarchy, or a taxonomy, of the classes. We can use hierarchical relationships to allow distinct classes to share common functionality. In programming, we very often, so often, we need multiple, slightly different, but similar things to exist. Hierarchies allow us to structure our code, to give us a data structure to do this easily without having to write code multiple times. We implement the common shared behavior in the parent class and the unique behavior in the child classes. Was this whole thing just about programmers being lazy and not wanting to copy and paste? Yeah, maybe. Maybe it was. But, it's also better. not just because of laziness. If we make a class that's a child of another class, but we don't write any new code in this child's class, we've just created an object that behaves identically to the parent. We've cloned it. Another version of the parent, or a copy. Unlike with biology and the dang mutations, being a child of another class makes it a fully fledged version of that class, and broadly speaking, we can do anything that that parent class can do. Let's write up a class on this whiteboard. I'm going to write a class here and write some members, and they can be whatever. This is just an example. To extend the class, which is what we call creating a child of a class, extending it is a vocab term for us. It's like if I put a piece of transparency paper over this class on the whiteboard, and now I can add some new members. I can extend the class with some new members on the child. If I look at the code of the child's class on its own, it doesn't look very impressive. It's just these new members, and it can look pretty empty. In C# on my computer, I'm looking at this script on its own, what I've actually written for the child. Again, it can look kind of empty. But because it's inheriting members from its parents, it's got all of that functionality too, and we can use this child object in the same places we could use the parent. That's the short version. There's a lot of more complicated ins and outs and details. For example, thinking about types. Child objects can be declared as the type of their parent object. They can have multiple types. It could be a parent type or the child type. It gets a little more confusing. And then there's also scope and dealing with scope and how we allow things to inherit or not inherit and overriding and all that stuff. And we'll get to some of that in the example video. But I just want to say for now, whenever you're tied up in the weeds of inheritance, I just want you to back up and think about the fundamentals here. What are the members? Where does the object? What's its parent? Where does it belong? What are the relationships it has? I like to make little flowchart diagrams all the time to help me visualize my code, because there's very little on the screen while I'm programming that gives me, the programmer, this real-time feedback about what the object's class is and where it is in the hierarchy. That's one of the more challenging parts of programming an object-oriented system, is that the syntax of the code doesn't represent its hierarchy very well. It's just sort of a word somewhere on the screen. And it can be tricky to remember where we are in the hierarchy or what this object is, and we write code in the wrong place. But that's fine. It's going to come with practice. We're going to get there. So if you ever get stuck in the weeds, I recommend making a visual diagram, just a couple of circles and lines on a Post-it note or something. And just having that there as a visual reference can be very helpful.